class, now we're on 6.4, and we are going to look at combustion reactions. This is another type of reaction. We already covered synthesis, decomposition, single and double displacement. This is the last one. This is combustion reactions. So many common reactions involve elemental oxygen. Oxygen is a major component of Earth's atmosphere, and it reacts with nearly every other element and many compounds. Both metals and nonmetals react with oxygen. For example, consider the way that oxygen reacts with tin. If we look at this first one right here, reacts with tin, which is a metal, and also with the nonmetals, carbon and sulfur. The first product, tin 4 oxide, remember this is a negative, a 2 negative, this is 4, and when it's reduced down, that's where you're seeing the 2. So what you would see is a 4 and a 2. You divide by 2, it still leaves a 2. So the first product, tin 4 oxide, is an ionic compound. The other two products, carbon dioxide and sulfur dioxide, are molecular compounds with covalent bonds. And yet all three elements react with oxygen in similar ways. Each of these reactions releases a large amount of heat and forms an oxide compound. An oxide member means there's an oxygen, a part of the compound. These rapid and exothermic means heat. Heat is given out, it's put into the environment, the surroundings. So exothermic reactions with oxygen are called combustion reactions. In these reactions, oxygen combines with elements or compounds to produce oxides. So in this form of combustion, this means that oxygen combines with elements or compounds and to produce oxides. So it comes together. So the compound that is produced will be some sort of a compound with oxygen in it. So hydrocarbons. We're now going to look at hydrocarbons, and I think let me show you what a hydrocarbon is. So some of the most important combustion reactions involve compounds composed of hydrogen and carbon. They are called hydrocarbons. If you're going into organic chemistry, all you will ever deal with is hydrocarbons. That is carbon and hydrogen, a part of a compound. That's what organic is dealing with carbon. Carbon and a lot of hydrogens are attached. So we just call them hydrocarbons. These reactions are important because fossil fuels such as coal, oil, and natural gas are composed primarily of hydrocarbons. The combustion reactions of fossil fuels produce most of the energy used worldwide. The combustion of coal and natural gas produces most of our electricity, and the combustion of gasoline powers most of our transportation. So the term hydrocarbon is just a generic term for carbon and hydrogen. We don't talk about how many numbers because there's so many different compounds. It's just C and H. We don't talk about it. There's nothing specific about it. When you hear hydrocarbons, it's just carbon and hydrogens. That's it. Just a generic term for all of these. So combustion of hydrocarbons. When hydrocarbons react with oxygen, they form two main products. They form carbon dioxide, as you can see here, and water. For example, methane, here's a hydrocarbon, is the main component of natural gas. The combustion reaction of methane follows the balanced equation, and here's the balanced equation. So this is a combustion. So two types of combustions. You have combustion compounds that produce compounds with oxygen in it, and then we have combustion of hydrocarbons. And hydrocarbons, the product is always carbon dioxide and water. You just have to balance it out. So when you see something with this, a CH, and oxygen, diatomic oxygen, reacting with each other, the products will always be carbon dioxide and water. You just have to balance it out. So the combustion, so in this case, so we look at the bottom one, which is octane, and octane is a component of gasoline. This compound also reacts with oxygen to produce carbon dioxide and water, shown in this balanced equation. That's because hydrocarbons, when reacting with oxygen gas, which is diatomic, always produce carbon dioxide and water. Those are the products. Water in this case is water vapor gas. So this is a slide from one of my other courses. It's just another breakdown. Combustion reactions are characterized by the reaction of a substance with oxygen to form one or more oxygen-containing compounds, including water. Combustion reactions are exothermic. That's just a fancy way of saying they put out heat. So think of a fire. When you're starting a fire, it will warm the room. Compounds containing carbon and hydrogen, known as hydrocarbons, are carbon, hydrogen, and oxygen, always form carbon dioxide and water. So carbon and hydrogen, and they react with oxygen, will form carbon dioxide and water upon combustion. These reactions are commonly used to generate energy from fossil fuels. Methane, fuel most often used in gas ovens and stoves as an example. So here's a generic equation for it. You have a hydrocarbon in the presence of oxygen, gas, diatomic oxygen, produces carbon dioxide and water. So the combustion of sulfur produces sulfur oxides. So non-metal elements often react with oxygen to form many different compounds. For example, the combustion of elemental sulfur produces several different oxides, including sulfur dioxide. So you can see it's SO2, sulfur dioxide, that means 2, sulfur dioxide, and sulfur trioxide, SO3. These compounds, commonly referred to as sulfur oxides, are toxic gases and contribute to the environmental issues such as acid rain. Because coal containing a small amount of sulfur in addition to hydrocarbon compounds, the combustion of coal leads to the release of sulfur dioxide into the atmosphere. Okay, so let's take a look at some examples here. Write a balanced reaction for the combustion of calcium metal. So basic combustion reactions, you can also follow the electrons. An oxidation reduction occurs. And how do I tell you how to do that? Look at the compound, put it in its ionic form, and you can see that calcium loses the 2 electrons and is taken by the oxygen. So calcium in this case is reduced. Oxygen is, ignore that. Calcium is oxidized and oxygen is reduced. I meant to say that to test you. So then you balance the equation out. And when it talks about, if it's giving you the oxygen, then remember, this is also a form of combustion because it's creating an oxide compound. And this is a synthesis. This is coming together. A plus B equals AB. Now, combustion is entirely different. It has to deal with a hydrocarbon, and in the presence of oxygen, gives you the products. It's telling you what the products will be. You won't even have to figure that out. It's carbon dioxide and water. So write a balanced equation. So let me go back. You know what? Let me go back and give you... let me take a step back. Let me break this down. I think I should expand on this. Right, so you're going to write a balanced equation. So combustion reactions with oxygen gas are 2 reagents. The reactants are calcium and molecular oxygen. Molecular oxygen is O2. What product would these 2 elements form? In this reaction, calcium will lose electrons to form calcium ion, which is the Ca2+. Each oxygen atom will gain 2 electrons to form the oxide ion, which is O2-. The compound formed from these 2 ions must have the formula of CaO. Why is that? Because, remember, if you crisscross these, you have a 2 and a 2, you can reduce this down, which gives you calcium oxide. The 2s are still there. We just, divide them out. Each of these, each oxygen, this compound formed from these 2 ions must have the formula calcium oxide. So when you write this as a product in a reaction, we balance the equation by adding the coefficient 2 in front of the calcium and in front of calcium oxide. Why? Because there's already a 2 for diatomic oxygen here. So hopefully expanding my explanation helped a little. Okay, so let's look at this one. I'm sorry, I dropped my pillow. All right, write a balanced equation for the combustion of propane gas, a common fuel used for home heating, cooking, etc. The formula is propane. By the way, if you guys are taking organic, the naming and where these come from has to do with how many carbons. It's not, so this is propane because it's 3, pro is 3, octane is 8, oc is 8, so that's where it is, it's 8. So in case you're wondering where some of this stuff comes from, when you get to organic, you will learn a whole new naming, and it's based around carbon. So butane, bu is 4. So that tells you have 4 carbons in it. Methane is 1 carbon. Okay, so let's go back. So propane is C3H8. So it's a hydrocarbon, and it's in the presence of oxygen. So I already know that the products here are going to be CO2 plus water, and I need to just balance this out. We begin with the two reactants, propane and elemental oxygen. The combustion of hydrocarbons always produces two products, carbon dioxide and water. Once written, so you write the equation out, so write a skeleton equation and then start balancing it. And as long as you write the correct compounds, then you can balance it out. We balance the carbon atoms out by adding a 3 in front of the C in CO2. We balance the hydrogen atoms by adding a 4 in front of water. And finally, we balance the oxygen atoms by adding a 5 in front of the O2. And that should allow this to be balanced out. So let's make sure we have 10 oxygens on this side. We have 6 and we have 4. So there's 10 on that side. So yes, this is balanced out. All right, so show the net products from the following combustion reactions. Balance if necessary. So now you are being asked to put these products together. Look at the type of reactions they are. So this is an A plus B, so it's going to be AB. Now you can figure out how to put this together. Same here, A plus B equals AB. So knowing what type of reaction it is tells you what should be on the product side, and then you can put it together. This is another A plus B, it's a synthesis. This is a hydrocarbon, so the combustion reaction. So we know that the products are going to be CO2 plus H2O and then balance it out. So I'm giving you all this information. Put it together and balance it out and see. But look at the type of reactions. The type of reactions, that's why you're learning what type of reactions they are. That will tell you what needs to be on the other side. The combustion of hydrocarbon produces what two products? I've already said it a few times. Hopefully it's sticking. That's going to be C. What are the correctly balanced products from this reaction? So this is one, again, that you should do, and then check the answer, which I'm always giving you the answers so that it will help you understand if you're on